Swayam Prabha. Digital India. Educated India.
Discussing the module 7 of the organic chemical technology course. We have discussed the various petrochemicals which are manufacturing. So now the two important topic that is remaining, that is the aromatic production and the aromatics, different aromatics which are find wide application in the organic chemical industry. So we will be discussing. So let us discuss first the aromatic production, because here the production of the aromatic, there are a lot of the changes in the process technology from the initial stages where the aromatics were only available through the coal chemicals route, means the coal carbonation from the coke oven plant. But with the coming of the catalytic reform, with the development of the catalytic reforming process, and at the same time with the pyrolysis gasoline which is rich in the aromatics, and some of the condensate fractionation, some of the high aromatic naphtha where the de-aromatization of the naphtha that can be done. So with the coming of these processes plus some of the other processes that has been developed in case of the aromatic production, production technology, aromatic conversion technology, where some of the aromatics like toluene or the metagerine, they are having the lesser use. So conversion of these aromatics to the more value-added aromatics, and that has, these are the some of the advances that is thing. Another development is the cyclopus. So all those things that we will be discussing in the coming in this lecture. So first the introduction about the aromatics, importance of the aromatic, various routes of the aromatic, catalytic reforming, aromatic. Although the catalytic reforming part we have discussed in detail in the petroleum refining, the process is the same, only here the our catalytic reforming, that is more with more emphasis on the aromatic production, not the gasoline, and the development that has taken place in the process itself, and just to have the higher aromatics in there. So then the aromatic complex, paraxylene manufacture, which is one of the again very important aromatics, and the huge amount of the paraxylene that we are using in the manufacture of the DMT or the terephthalic acid. Then we will be discussing about the aromatic conversion process, and in the last the cycler process, where we are making the aromatic from the propane and butane by the cycler process. Aromatic hydrocarbons, especially the benzene, toluene, xylenes means the paraxylene, orthoxylene that we are more interested, ethyl benzene, that is also because one of the important feedstock for styrene, are the major feedstock, because during the process all this benzene, toluene, xylene, ethyl benzene that will be there, are major feedstock for a large number of intermediate which are used in the production of synthetic fiber, resins, synthetic rubber, explosive, pesticide, detergent, dyes, intermediates, and the pharmaceutical industry. Huge amount of these aromatics we are using. So the benzene is one of the most versatile chemicals used for variety of intermediate and pesticide. Benzene also find application in the manufacture of large number of aromatic intermediates and pesticide. Benzene world capacity of benzene from steam cracker and refined steam is 56 million tons, and the capacity is expected to reach 62 million tons. Other aromatics which are of the important product from the aromatics that you are getting, styrene from the ethyl benzene, cyclohexane from the benzene, because cyclohexane that is finding application in the manufacture of the caprolactam. First benzene is converted to cyclohexane and then cyclohexane, that is being other by solvents also using chlorobenzene and aniline. These are two another very important product which you are making from the benzene, because the aniline, that is the raw material for the dyes intermediates. Another product of the benzene is very important, because we have already discussed that part, that is the linear alkyl benzene LAB, which is because of the coming of the refinery, benzene is available, and so that has changed the whole actually the detergent industry status. Another process, as I told you, the cumene from the cumene root, that is for the making of the phenol, that is also the major consumer of the benzene. So here while making the phenol, other actually outlet, because this is not a complete, it will be discussing while discussing the aromatics in detail about the individual aromatics, where you see the cumene to phenol, phenol to bisphenol, and bisphenol to polycarbonate, like that. The continuous use of these chemicals are there. Toluene, that is having the less application if we compare with the benzene or the paraxylene. So it is used as a solvent, because the alternative processes which we are now using the benzene, that was from the, just like you take the case of the caprolactam, that was the actually the benzene route that we are, benzene to cyclohexane route that we are using, but the toluene to benzoic acid and then the raw material, that is also one of the route. So this is the other uses of the manufacture of the toluene is the benzoic acid, one of the very important organic acid which is being used for the making of the large number of the organic chemicals. TNT, trinitrotoluene, because that was the explosive earlier, although now the new bit of the explosive that has come, but the TNT, that was one of the very important explosive during the World War I and II, and the lot of the development that was there in the catalytic reforming process also to produce aromatics, and so that aromatics which was required either for the synthetic fiber industry or for the this explosive. Caprolactam, chloroderivatives, nitrotoluenes, toluene sulfonic acid, toluene sulfonide, benzaldehyde. So these are the some of the other product of the important product of the toluene. Xylenes are another important aromatics. The paraxylene is used for the manufacture of the DMT and terephthalic acid. Orthoxylene is used for the manufacture of phthalic anhydride, because phthalic anhydride that is find wide application in the paint industry as plasticizer. Earlier the route was through the naphthalene route, that was the route available earlier, but now the all the phthalic anhydride that is being produced from the orthoxylene, because orthoxylene is one of the major byproducts which we are getting while making of the paraxylene. This is the actually status of the, and if you see the major portion that is going for the thiolbenzene, cumene and other products, that is also there, and nitrobenzene or the anilines, but major portion that is going to ethyl benzene and ethyl benzene to styrene. This is for the styrene, that is the gasoline, you can, because this is the very high octane number that you are having, but other applications are also there. Similarly, the paraxylene, this part is maximum for the manufacture of the polyester, means the terephthalic acid. Other uses are also there, but these uses are less than what we are having. A major portion that is going for the manufacture of DMT, that was the earlier route for getting the polyester. Now the terephthalic acid or the purified terephthalic acid, which is the raw material for the or the monomer for the your polyester industry. You see the one of the we forgetting the aromatics that was from the coal, and that is one of the various your product that you are getting from the coal carbonation unit, and the yield around that is you see the yield of the benzene, toluene and xylene, that is much less than what you are getting from the petrochemicals, and that was the reason why this is the figure which I was telling, 2 to 8 kg benzene, 0.5 to 2 toluene and 0.15 to 0.5 kg of the xylene. This is the amount of the aromatics that we are getting per ton of the coal. So, the definitely this is a very small quantity, but you see the before coming of the catalytic reforming process where we are making the aromatic, this was the source available for the getting of the aromatics which were having the large application. Another route that is not the exactly the purpose of the production of the aromatic, that was for the olefins, but during the steam cracking process we are also getting a complementary steam, that is the pyrolysis gasoline. So, that is why I have added this part, the steam cracking of the hydrocarbon. So, steam cracking of the naphtha and the light hydrocarbon like ethane and the propane produce liquid product pyrolysis gasoline, which is rich in aromatics containing about 65% of the aromatics, about 50% of which is benzene, about 30 to 35% of the benzene produced worldwide is from the pyrolysis gasoline. Because the as I told you earlier also while discussing the cracking, naphtha cracking, the pyrolysis gasoline is more in case of the when you are having the naphtha cracking, and as we are having around 52 to 55% of the total feed as a naphtha for the steam cracker, so definitely the amount of the pyrolysis gasoline generated, that is large. So, the major route for the aromatics, that is the catalytic reforming process. Catalytic reforming means the same process which we discussed in case of the petroleum refining, the module 6, that was the catalytic, the same similar process we are using here also. So, catalytic reforming is a major conversion process which converts low octane naphtha to high octane gasoline and produce aromatic rays in BTX. Major reaction involved are dehydrogenation of the naphthenes to aromatics, isomerization of the paraffins and naphthenes, dehydrocyclation of paraffins to aromatics, and the hydrocracking of the, because this is the side reaction that already we discussed in detail about the reactions and the feedstock, what are the various controlling parameter. And another process which is one of the commercial installation is also there in, I think it is in Nigeria about this process. This process BTX is produced by de-aromatization of the propane and butane. The process consists of the reaction system, continuous regeneration of the catalyst and product recovery. Catalyst is a proprietary zeolite incorporated with a non-noble metal. Here also we are having this reserve the reactor, preheaters are there just like the catalytic reforming process, and we are getting the aromatics from propane and butane. Another process, the hydro dealkylation and disproportionation, because these are the process that we are using for the dealkylation of the your toluene or the disproportion of the toluene, and so that because to get the more value added product. So, disproportionation also we are using in the process of the xylene, para-xylene manufacture, where the meta-xylene that is having the less use of the meta-xylene that is converted to para-xylene. So, isomerization, disproportionation or the isomerization part that is there. So, in case of the, this is the actually so far the disproportionate is concerned, this is only for the toluene, because in that process while making the paraxylene, some toluene is also formed. So that toluene that can be, so some of the units they are also having the part of the, both the process are there. In case of the paraxylene, the isomerization, the disproportions are dealkylation. De-aromatization of the naphtha, as I told you, the some of the naphtha they are very rich in the aromatic. So instead of going for the catalytic reforming, this process involves the removal of the extraction, not the extraction of the aromatic from high aromatic naphtha feed without prior refining, because now the number of the your solvents that is available, and so from that we are able to extract the aromatics from the naphtha. Here we do not need any further reforming process for this making of the aromatic. The process is useful for naphtha having high aromatic. Jet forming process, this process use metallosilicate zeolite catalyst to promote dehydrogenation of the paraffins followed by aluminization and dehydrocyclation of paraffins followed by the aluminization. QTI pyroforming process, this process uses a shape selective catalyst to convert C2 and C3 paraffins to aromatic. Chevron Aromatics process, it is similar to the conventional catalytic reforming process, and L-type zeolite catalyst that we are using. Isomerization and the isomer process, as I told, the isomerization process is also the part of the integral part of the now the paraxylene process. This process consists of the conversion of C8 steam into valuable ortho and paraxylene having isomerization and the isomer separation stage. These are the two stages involved in case of the isomerization in it. Now let us discuss in very brief about the catalytic reforming, which we discuss in detail in the module 6, that the catalytic reforming is a key conversion process in petroleum and petrochemical industry. From the petrochemical point of view, it is important for the production of the aromatics and the hydrogen that we are getting as a byproduct, and from the reformate we can separate this aromatic. The catalytic reforming gives flexibility to meet gasoline octane number requirement. It can also make aromatics of high market value. Catalytic reforming is a refining process that uses selected operating condition and selected catalyst to convert the low octane naphtha to the high octane naphtha and the more aromatics. Basic objective of the catalytic reforming is, as I told you, the refinery, it is the sum of the catalytic reforming process in the refinery. They are producing the benzene or separately only the xylene, as in case of the BRPL, which I told you earlier, the Bokaigaon refinery and petrochemical, they were making earlier DMT, but now that plant has been closed because of coming of the purified telecase in the market. So they are having the only xylene plant. Panipat refinery, IOC Panipat refinery, they are having the both catalytic reforming and the paraxylene plant is there to produce high value aromatic hydrocarbon such as BTX. So these are the some of the objective of the catalytic reforming. Basic steps, just I will go quickly because already we have discussed the feed preparation, temperature control reaction in the reformer and product recovery. Various types of the catalytic reformer are the semi-regenerative, non-regeneration, cyclic, moving bed. Two types of the reformer reactors are in, it may be radial or the axial flow. These are the various steps involved in case of the catalytic reforming, naphtha hydrotreating, catalytic reforming, catalyst circulation and the regeneration. These are the some of the reaction, dehydrogenation, the main reaction, isomerization, dehydrocyclation of the paraffins, hydrocracking reaction that is taking place simultaneously, because that is the high temperature environment is there, and so the that is undesirable part of the major units of the aromatic complex, because that was the catalytic reforming process, because we are making the aromatics. Then the next section in case of the aromatic plant, that may be the separation of it. So, we are having the PSA, pressure swing adsorption, BTX separation, pressure swing adsorption that we are using in case of the paraxylene separation, that is the Parex process, xylene fractionation unit for separation of the orthoxylene from meta and the paraxylene, because here the boiling point of the orthoxylene, meta and para. Orthoxylene is around 140 degree centigrade, and meta and paraxylene they are the close boiling component around 136 to 137 degree centigrade. So, the separation of the meta and paraxylene is there. So, that is the two process we are using. One, the I told you the pressure swing adsorption, second process that we are using the crystallization. So, adsorption here is the Parex process, and there are also combination of these two processes, hybrid process, where the crystallization and the adsorption both are. The adsorption process Parex, that has been developed by UP. So, both the process are there, hybrid process where the combination of crystallization and adsorption is there. So, what are the steps in case of the BTX, because as I told you, the boiling point of BTX, benzene, toluene, xylene is different. So, depending upon your requirement, a definite fraction of the naphtha that you will have to take here, and here also one of the requirement that will be the naphthenes rich naphtha, so that the more and more aromatic process. So, first step in making BTX is to distill of a suitable fraction rich in the naphthalene, which serves as the precursor for the aromatic. Catalytic reforming or a steam cracking to produce aromatic, because here the pyrolysis gasoline that can be combined after the hydrogenation, but the removal of the impurity, then it can be combined with the reformate for separation of the aromatic. Preliminary treatment of discrete fractionation and selective hydrogenation, essentially pyrolysis gasoline, because that hydrogenation that we are doing in case of the pyrolysis gasoline, because a two-stage process is there. Then solvent extraction, because during the your catalytic reforming process, aromatics and non-aromatic both are. So, non-aromatic component that has to be separated. So, various separation of the aromatics, we are having the liquid extraction, extractive azeotropic distillation, adsorption and the crystallization. Process variable in case of the aromatic processing, the catalytic reforming, feed quality, temperature and space, because if you are using the feed quality means if you are interested for the only paraxylene, then definitely plus 110 fraction of the naphtha that has to be taken. If you are interested in all the three products, then the lower boiling point is naphtha that will be used. So, this was the already we discussed n plus 2a, importance of the n plus 2a, because that will. So, the effect of the feed quality on the aromatic yield. Lighter fraction have a poor naphthalene and the aromatic content are therefore poor feed for the reforming. Low initial boiling point feed results in lower aromatics and hydrogen yield. Heavy fraction have high naphthalene and aromatic hydrocarbon content, therefore good reforming feed, but tendency of the coke formation is high in case of the heavier fraction. This is the typical aromatic complex where combination of the catalytic reforming and the separation we will be discussing separately, then it will be more clear, where we are having the extractive distillation for the separation of the aromatics from the non-aromatics, then the clay treatment, and then the various distillation columns we are separating the benzene, which is the lower boiling point, toluene and xylene's mixture that will begin, and that xylene mixture which C8 hydrocarbons, which will also contain the thylobenzene, then the separation of the ethyl benzene, and further fractionation that will give the orthoxylene, and then a mixture of meta and paraxylene which will be separated by crystallization and the adsorption process. This is the process which I was telling, the two important feedstock for the aromatic production, that is naphtha, and this is the pyrolysis gasoline. So, two stage hydrodesulfation process in case of the pyrolysis gasoline, and then the naphtha, it will go to the catalytic reforming, separation of the non-aromatic fraction, and then the clay treatment, and finally it will go to the different columns for the separation of the benzene, toluene, and xylene, and xylenes and ethyl benzene. So, this separately, because this is the part up to. So, many of the refineries what they are doing, they are separating only benzene and rest of the steam that is going to the fuel steam. But in case of the, if you are interested for paraxylene, then all the this further it has to be separated. This is the process we are using in case of the separation, because this is the again whatever the your after the separation of the toluene and ethyl benzene, mixed xylenes that we are getting containing the orthoxylene, paraxylene, and metaxylene, and the xylene or meta and para, they are having the close boiling point. So, they cannot be separated by the distillation, but orthoxylene which is having the around 140 degrees centigrade boiling point, so that is separated by distillation here. Here you see this is the separation of the xylene and meta and ortho, that is the P paraxylene rich steam, and so that is the orthoxylene that you are separating from this column. This is the column where the orthoxylene, because you are mixed xylene and the C9 hydrocarbon first that has to separate before it is going for the separation of orthometa and paraxylene. So, here you see this is the metaxylene that is separated at 140 degrees centigrade. Then we are having a mixed xylene, means the para and metaxylene. So, separation, that was the initial, because this was the development in case of the aromatic production. Otherwise, earlier this crystallization process was not developed well, adsorption means the Parex process was not developed. So, removal of the separation, that was a problem. So, this is the how we are having the two processes now, it is available and that is being used by different petrochemical complexes, where we are making the paraxylene separated by crystallization, or it may be the adsorption, where we are using the Parex. Just like we discussed about the LAB, then it was the Molex. In case of the olefin, it is the Olex process. Here it is the Parex process. Then the again after the separation from the crystallization and the adsorption, again it is left with the mixed xylene. It will be more metaxylene. So, as I told you, the metaxylene, that is having very less application. So, isothalic acid, that is the only major application of the metaxylene. So, what we are more interested in case of the your paraxylene plant, it is the more production of the paraxylene. So, whatever the metaxylene that is left, that is going to the isomerization section. Similarly, the toluene which is available in the process, which is having the less use. So, we are having the toluene disproportion, which I told the various aromatic conversion technology. So, this is the another process, and that is the two section. In some of the plants only isomerization section is there, and in some of the both the units are there where the isomerization and the so from the isomerization again we are separating the paraxylene, because you see the major, as I told you, the major portion of the paraxylene is for the manufacture of terephthalic acid, and with the coming of the polyester and the terephthalic acid DMT, which is the monomer or which is the major raw material, there has been lot of the impact on the synthetic fiber industry. So this is the process of making, because these are the units which are there in case of the, apart from the catalytic reforming. Catalytic reforming for the production of the aromatics, and then the separation of the aromatics, benzene, toluene, ethyl benzene, xylenes, and then the your conversion of the metaxylene or the xylene to the more valuated product paraxylene. So disproportionation, or it may be the isomerization in case of the metaxylene to para in the ortho. So that is how the your paraxylene plant, which are the part of the DMT or the TPA manufacture, they are operating. So this is the actually, as I told you, the feedstock that is playing important role in the production of the products we are getting from the catalytic reforming. And as here our objective in case of the petrochemical complexes is the production of the benzene and the xylenes, because the benzene that is required in case of this where the LAB they are also making, or it may be the other uses for the caprolactam, as in case of the GCFC they are getting benzene from Indian oil. And so the xylenes, that is the fraction, you see the xylenes, the fraction of the naphtha which will be taking here 60 to 90, 90 to 110, because if you are going beyond this, more formation of the toluene and xylene will be there. So our interest is here in case of the benzene, because you see the refineries they are operating both in the gasoline, and just like BPCL, you take the case of the BPCL, they are separating the aromatics in case of the Reliance, in case of the Panipat refinery, this Madras refinery, MR, these all Madras refinery are now the Cochin and this Madras or Chennai petroleum refinery, that is taken by the Indian Oil. So in all they are all the Haldia refinery, they are producing the benzene or the xylenes depending upon the requirement. So you will have to go for the choice of the feedstock accordingly, and the different fraction of the naphtha which you will be taking. And if you are using for the octane blending, then a broad range of the naphtha that you can take. So for the xylene is concerned, only this fraction of the xylene that has to be taken. These are the some of the units which discuss in the flow diagram for the paraxylene. Just I will go quickly. The pre-treatment unit, this unit is used for reducing sulfur content, because the removal of the sulfur, that is very important. The reformer unit, catalytic reforming unit, to get the maximum amount of C8 aromatics by reforming process. Similar to the catalytic reforming process, we are having the same type of units, same type of the operation that we are doing, only our objective is towards the more and more benzene or the xylene. Then the fractionation unit for the separation of ortho, meta and the paraxylene from the combined C8 reformate, and isomerate from the isomerization unit after the clay treatment. Parex unit, this unit is for the separation of the paraxylene by selective adsorption using molecular sieve followed by desorption. So this was the real breakthrough, we can say, in the production of the paraxylene, the coming of the UOP Parex process. Now other processes they have also developed this process for separation of the paraxylene, but it was the main actually the role of the UOP which developed this process. Other method for separation of the paraxylene is the crystallization process, and we are using this process also in some of the plant. And Reliance, they are using the crystallization process for the separation. Other units, they are having the Parex unit for the separation of the paraxylene. Then the isomerization and the dealkylation, this is also the part of the many of the refinery. Isomerization of the C8 stream from Parex unit reaching the meta and the orthoxylene and ethylene, but because the orthoxylene that will be very less, ethyl benzene to para-xylene, which is sent to the fractionating unit for separation of the high-end component. The bottom of the column is recycled for further recovery of the xylene. So, this is the Parex process where the continuous adsorption and desorption that is taking place, and then the recovery of the extract, recovery of the desorbent that is there, and so finally we are separating your para-xylene. So, this is the process, this is the continuous operation of the rotary valves are there, and the here input of the feed and then the feed outlet, all those, and the addition of the desorbent, all this taking place simultaneously in this continuous adsorption column. The same process is there also in case of the Molex process. Now let us discuss in very brief about the various aromatic conversion process. One of the very important is the isomerization process, isomerization of the meta-xylene to para and the ortho-xylene, transalkylation and disproportionation, that is the transalkylation disproportion of C7 and C9 stream, toluene disproportion of two xylenes and the benzene. Because these are some of the options available for converting the low value product to the more value added product. Or in the process it is because our, as I told you, in case of the xylene, if you are making some toluene will be also there, meta-xylene will be there. So, how to utilize this effectively to increase the productivity or reduce the cost of the para-xylene manufacture, that will be the isomerization or the toluene disproportionation, that may be there. Aromatization, that is the conversion of the light hydrocarbons to benzene, toluene and xylene, similar to your reforming process. These are some of the aromatization process, that is cycler process, aeroforming process, M2 forming or the jet forming. These are some of the processes for the aromatization. Now let us discuss about the cycler process, that is one of the very important route for making of the aromatics, that is through the natural gas. So, cycler process is inexpensive and plentiful as the LPG is there, even because you see the many of the refinery when the naphtha that was surplus, they were thinking to go for the LPG mode, cracking of the naphtha to LPG mode, or in the LPG that is available from the various process in the refinery itself, or LPG that we are also separating from the natural gas before it is being supplied to the fertilizer plant. So, this LPG that can be used for manufacture of the aromatic. This requires minimal feed treatment and product purification requirement and simplicity in the operation, which we are facing in case of the other conventional process. So, feed is propane and butane, pentanes or mixture of these. Liquid product largely BTX, essentially free from C6C9 paraffinic and naphtha. So, this is more pure form of the product that we are getting. Preparation of the benzene, toluene, xylene charges are very little with the composition of the feed. This is the typical yield of the aromatics depending upon the feed. Either you take the propane or the butane, you see the difference is not much in your aromatic yield, is whether the propane or the propane butane mixture that can be taken. So, very high hydrogen yield, 5.5 to 6% of the feed, purity is about 95%, and so this hydrogen that can be used elsewhere. So, this was the cycler process that is being used for the these are some of the series of the reaction that is taking place from the in the cycler process, where you are getting the hydrogen, which I told you, the high purity hydrogen that you are getting, and this is the aromatics that you are getting. So, these are the series of reaction that is taking place in the process of the conversion of the natural gas to the or the propane butane to aromatics. This is the typical LPG aromatization unit developed by the UOP, and where again we are having the series of the reactors, and this is the this is the stack interheaters, and this is the reactors. We are having the stack reactor. This type of reactor also not being used in case of the catalytic reforming. So stack reactors and the interheaters are there, and finally after the your conversion, it is going to the, we are getting the aromatic gas. So this is the similar to your catalytic reforming process, stack reactor, one reactor, second. So and the finally continuous regeneration is also taking place. So this was about the aromatic production, and because you see the now the many of the refinery, they are going for the integration of the refinery with the petrochemical, or even the ONG, the organization which are producing the your this gases, only the gas, the oil and gas business, ONGC, now they have entered in the petrochemical business also. So the aromatic production, that is going to be enhanced by the various operation, because the availability of the raw material. Another route that may be the condensate, which are the aromatic rich naphtha, that can be separated. So these are the some of the process we discuss in the aromatic production, and the next lecture will be discussing in detail about the various aromatic products, why the importance of the aromatic is there. So the changes in the refinery operation, especially with the coming of the polyester and the LAB plant, because many of the refineries now they are operating, they are catalytic reforming for the production of the benzene as well as paraxylene, or this they are having the same. You take the case of the Patal Ganga. When the Patal Ganga was operated, started, it was the polyester, the PTA and the LAB. Similarly, when the Nirma they started, they need the benzene for the LAB plant, that was supplied by IOC. Similarly, Gujarat State and Fertilizer Complex, they use the benzene from the IOC. So this was the importance of the aromatic production unit, and so the next lecture, that will be on the various aromatic compounds.